Okay. So again, on chapter 6, we're talking about files. We're going to lead us to exceptions. I put a video out there. Some of you have watched already from the lab yesterday. Just kind of what I was thinking. Okay. I will say that in my zest, anyway, to make sure I was calling main at the end. I called main twice by mistake. So my program kept ending. I hit the 9 to end, and then pop it back up again. I probably spent an hour going through everything I could think of. Finally, I'm like, it's calling it again. So I'm like, it's calling it again. So yeah, don't call main more than once as a general rule.
Or don't put the main inside of a function and call it again.
Yeah, no, that's not good either. No, that's the fun. No, it's not good. Anyway, the video's out there. And I think the problem is with us that assignment was that when you're entering in the numbers, you still can't test if it's an and or not, right? You don't know how to do that. Because you can't, if you try to test it after you've already done the int function, it's already blown up by then. Okay. So we have to wait until we deal with exceptions on Friday. So that'll fix that one. But the functions themselves should be standalone and should make sure that the preconditions and post conditions are being accurately handled. Okay. That's just the way to think about what we do. Okay. So today, we're not getting anything we've done before, but we're adding some new stuff. We're adding the ability to write to files. So far, everything we've done has been held in memory. Memory is volatile, right? Memory, the computer power goes, the memory is gone. Okay, so it's not a good solution. You wouldn't want to run an accounting system all in memory, right? Because somebody hits the power plug or the power goes out, you've lost all your records. Okay, so we have to move the data from the volatile memory into a more permanent storage. I'm going to put permanent in quotes because no storage medium is permanent. So there we're typically talking hard drives, which used to be magnetic disks and still are sometimes. But more and more now, they're the flash drive kind of storage. Okay, both of those will fail at some point. The flash drives in particular are interesting. They're a ton more reliable for a shorter period of time than a traditional hard drive would be. Okay, they're faster, they're smaller, they can really increase performance. But when they're gone, and that's a lot less of the time than a hard disk, the typical hard disk. Yeah. So anyway, that's what we're talking about here. We're moving the files there. Okay. Just some terminology here that we typically say that we write data to the file, or we're moving it from our program in memory onto the disk. And then the other way around is reading data from the file back into memory. Okay. We don't really directly access things on the drive itself. We have to move it back and forth. Okay. So the general process we're going to have here for all of this, we're going to start by opening the file, of course. Okay. That means we're going to have to use the operating system. So sometimes the instructions may vary just a little bit, especially when it comes to directories and things like that, how things are stored. But we're going to open up the file. We're going to assume that we have rights to open up the file, all that stuff. Okay. Once it's there, we're going to process the file in some way. That's either reading to the file, reading from the file, sorry, writing to the file, whatever we're going to do. And it's also important that we close the file at the end. If we don't close the file when we're done with it and the program dies, it will close it for us. But it's just not good practice. Okay? You want to make sure you're taking the time to clean things up as you're moving on. Okay? And pretty much any kind of program that you write that does much of anything is going to need to have some ability to write things to a file. Even a game is going to have where you can save points or save high scores. All that stuff is going to be done in a file. Okay. Oh, one thing I do want to say about homework. I graded the homework. It was due Friday, I guess. A lot of you on the kinetic energy did not do data validation. So those entering the mass and whatever, those needed data validation loop. So look in the homework comments. If you lost points, that may be where it was. Okay. Okay, anyway, back to this. Okay. So we open the file, we process it, we close it. We have a couple of types of files that we can be dealing with. The first is a text file. A text file, we also call it a plain file or a plain text file. It's just plain ASCII or sometimes Unicode characters. All of our Python programs are plain files. We can use a text editor to look at them, all that stuff. Okay. There are also binary files. A binary file is something like a Word file. If you've ever popped up a Word file into a text editor, it's a mess, right? It holds all kinds of metadata, all that stuff. Okay. So Python can deal with both of those types of files, but we're just going to deal with the text files. Okay, we're going to simplify our lives. Okay. Python does more than you can ever imagine that it could do. So it can certainly handle that, but we're not going to do that in this class. Okay. In a similar way, there are two different file access methods that you can employ. The most straightforward method is sequential access. With sequential access, you always go to the beginning of the file, you start reading until you get to the end. Okay. If you're not anywhere near old enough, but if you've ever used a cassette player, back in the day, I had a cassette player, that if you wanted to listen to the 14th song on the album, you'd start at 1 and hit fast forward until you guessed when you were at the right song. Okay. So that's sequential access. Direct access is like a CD or any of your, the digital options. You go directly to the song that you want. Okay. So again, Python does both. The direct access usually requires that you have fields set up with records, and it's a more structured kind of thing. Okay. And as Ben was asking, why don't we cover that? Well, complexity is one. This is an intro class. But the other is typically if you're programming something that requires direct access, you're going to pop in a database. Okay. So there are lots of database programs out there that you can use that would take the burden off the programmer having to manage that. A database is a very complex system to program, and you want to get help whenever possible, not have to do it yourself. I took a graduate class at Clemson where we had to create a database in C++. It was not a pleasant semester. And it still wasn't a very good database. I mean, it was okay. So yeah, that's why we do that. Okay. So when we're looking at our files here, we have the file name, which is what the file is called on the operating system. Okay, you have names.txt. Okay. And we're typically going to use a .txt extension because that's universally recognized as a text file. Okay. You could sometimes call it something like .dat, maybe for data, but I think that's less clear. Data could be binary data. So we're going to call it .txt. Okay. So that's how the operating system, when it's dealing with the hard drive or the storage device, deals with it. Okay. But we also have to have a file object on the programming side. Okay. So the file object, also called a file handle in other languages, it's the interface we're going to use. It's the variable that's going to hide that complexity. Okay. Behind the scenes, there's a lot messy going on, right? Your program has to go through the operating system to find the correct drive, the correct directory, the correct file, handle all those back and forths. Okay, we're going to forget about all that. We're going to abstract all that into this idea of a file variable or a file handle or a file object. Okay, that's what we're going to create. That forms the connection to the operating system and to the file directory. Okay, so when we go to open a file, I'm going to look. Share the screen here. Okay, something like this. So we can have some file variable. Oh, maybe it's not. Whatever you want to call your file variable. Typically, I'll call it something like in file, out file, depending on whether I'm reading or writing. Okay, it's going to be equal open. We're going to take the file name. Let's say it's going to be names.txt. Okay. And then it's going to be the mode. Okay. We have 3 modes that we can use when we're opening a file, depending on what you're planning to do. Okay. So I'm just going to go ahead and type up here, even though it's not good code. So the first mode is R, which means we're going to open for reading. When you open a file for reading, this is in the sequential access. It's going to put the file pointer, basically, if you have, if this is our file representing it, we're going to go here, okay, when we open that for reading, okay? we can then start doing stuff with the file moving forward. There's no way to skip ahead. That's if you want to open it for reading, that's what we're going to do. Okay. When you open it for reading, you're not going to be able to make any changes to the file. Okay. You bring it in, you do what you want, but you can't send stuff back. Okay. You can also open it for writing. Words sometimes look really dumb to me.
Just when you write a program, you write the same thing over and over, you're like, "Oh, that's all right."
But then it looks, yeah, it
Like
looks like
yes,
it's.
I kept answering like yes, I'm like, don't look right. That's
So I think this is destructive because what write does, when you open a file for writing, it moves the file pointer to the beginning of the file and starts writing. If you had stuff there, that stuff's gone. Okay. So if you had 10 names in your file, you open the file for writing and write 5 names, your file now has 5 names. Okay. First stuff's gone. Irretrievably gone, probably. To get it back would be iffy and take a lot of work. Okay. So only open for write when you're sure that you want it to be a whole new file, a whole new data. Okay. If you don't want that, you can open it in append mode. Not L. That would be llama mode. Nobody wants that. So open file for appending. Okay. So those are the methods that we have to access. Okay. So you can't change once you've opened the file, okay? But you can open it again. So if you wanted to read from a file first and then write to the file later, you would open the file for reading, read all the data, again moving it from the hard drive to the computer memory, close the file, reopen the file for appending, and then be able to add the end. Okay. We're going to go through some examples of how that's going to work. Okay. The questions on this so far. So the names.txt that we're putting there, that assumes everything's in the same directory, which is what we've been doing. Wherever IDLE puts it, or you've been doing your own directory. I think it puts it in whatever your operating system calls your home directory. So like on a Mac, it's users, your username, maybe documents, I'm not sure. Don't know where it puts it on Windows, but anyway. That assumes it's in the same structure, or same directory, or same folder. You can there do other things with directories. You can go all the way back to, if you're on a Windows computer, you could go back and do a C:, whatever. All the directory structures there. If you're on other systems, you could just do a / whatever.
That's rough on this hard drive, people. We gotta do that for all of them. You have to drive it to a file in the hard drive.
Yep.
I don't have to keep that on my clipboard.
Yeah, that's why it's better to just keep it in the same directory. Keep it, if it's in the same directory as your file, you don't have an issue. This does mean, this is something students always have an issue with. Any homework that requires a file, you have to upload the file to Moodle file. Because I can't do anything with your programs if you haven't included the file. Okay, so you can't put the directory information, but that just adds more stuff to it. Okay. So let's write this for real. It's going to say at this point, we don't have a file, so we're going to write to it first. So I'm going to say out file is equal to open names.txt. Open it for writing. It doesn't exist right now. Okay. Then all the operations on the file have to use that file name. So I can say out file dot write. Okay, pretty straightforward. Let's write our old friend Bob. Okay. Then we're going to close it. That's it. Okay. See if this works. We're going to blow up something. You could blow up something. Okay. There we go. Didn't do anything, right? Okay. Let's see if that's really there. God help me, I'm in Windows, so I don't really know how to get, is there a notepad, is that a thing?
Yeah, there should be a notepad.
Yeah, right there. Notepad plus, that'll work.
I'm gonna assume it's written in C.
Oh, go away. So that's in
This piece, I guess.
oh, it's in users desktop. Desktop thinks it is. There we go. All that to say, there's Bob. Okay. So on these programs, you don't have to use Python to be able to read the files. You can look at the file that you've written in a text editor, and it all should be fine. Okay. One problem is files typically should have a new line character appended to them. This is a normal way of doing things. Okay. So let's look at program 6.1 here. It's going to write 3 lines of data to a file. Okay. We're going to go ahead. They're calling it philosophers, but names works as well. So they're going to write, and you can just include that in there. Lock. I'll read you have those be the same time. Quote. Yum. I think there's a 3 continental rationalists, if I remember correctly. Not that it matters. No, they're not actually, because David Hume's not. So who knows what I'm talking about? Anyway, that doesn't matter. Okay, so we're going to write these to the file. We're going to close it. You can go ahead and change this just to keep it consistent with the text. Philosophers.txt. I'll run this now. Go. A new line. Again, it doesn't do anything. So it didn't tell it anything. If I go here. Philosophers, and there they are. We see each one's on its own line. Without the new line character, that would look really ugly. Okay. So if we want instead to be able to read this file, now we know it exists. Go back in here. And instead of opening it to write, and again, if I were to do this, I mean, I guess I could do this. Well, I don't want to do that. But if I would do an out file that right here with opening it for write with another name, then it would wipe out the first 3. So this we're going to call this an end file now. So we're going to read. You don't have to. These are just choices we make. This makes it clear when you're doing things. We're going to open it for reading. Okay. We have multiple ways we could read, but the simplest way is to say file contents or whatever you want to call your variable is equal to end file.read. Okay. That's going to return a string of the file. We're going to close the end file. And now we can just print the file contents. Okay, we run this. That printed the whole thing, right? So it read the entire file, and then put the entire file into that string, and it did just. So the read is the, if you're reading a document, you're going to try to get the whole thing at one time, then a read is what you would do. Okay. What's more useful is to read a line at a time, right? We can do something with these. Okay. So that's going to be our next example. And if you have questions along the way, then definitely let me know. So instead of doing a file contents here, we could do a line 1 is equal to end file dot read line. Okay. The read line again depends on those new line characters, and it's going to read all the way from the beginning of the file to the first new line character. Okay. So let's print this one. this should give me just the first guy, John Locke. Okay. So to get all three, I know there are three. We're going to talk about how we can deal with it when we don't know that there are three. So now I can do it 3 times. Oh, I'm only printing one. Okay, got them all. Okay. So there's the extra space here because we're doing the prints, which add a new line character. Okay. So note that when I restart the file, or when I close the file, I automatically get back to the beginning of the file. Okay, so I read John Locke, I opened it, read John Locke, read David Hume, read David Burke. Okay. Then when I closed it, I'm back to here. Okay, so if you run it again, you're going to be okay. Okay, so the read lines are a pretty useful thing to be doing. Okay. Okay, so if you're asking for input from the user, then you have to make sure that we want to open this for appending here. Okay, so now it's an out file. Again, you don't have to rename them, but it makes sense to do so. Let's say you're going to ask the user, new philosopher, or let's say new is equal to input. A new philosopher. Okay. So we now want to write this one. We want to write the file. Since we opened for append, it's going to go to the end. We want to write new, okay? But we're going to need to add that new line character, okay? So it will work properly with the other files, okay? So that's what that would do for us. Okay? That allows us to add to the end. If you wanted the user to create a new file, you would open it for writing, not for append. Okay. Now, sometimes when you have opened a file for reading, so we're going to go back to that, that new line character that's there is going to remain, and it may cause problems. Okay, so if I wanted to do the following, do line 1 is equal to in file.readLine, line 2 is equal to file.readLine. If I want to print line 1 and line 2, you'll see, it's hard to see because that's in the way, but you'll see that it automatically puts that new line character there, right? Well, I don't want that. So what I can do there is I can use the R strip. So I can say line 1 is equal to line 1.R strip. That's going to strip from the right, and that's on the right, which is what we want. The new line character, okay? And then I can do line 2 is equal to line 2.R strip. Again, stripping from the left, those new line characters. Okay. So now it's going to run them together, but it should at least, I guess we should have space. Okay. That gets rid of that character for us. Okay.
Why does it have the space in front of it?
Because the comma by default automatically puts space. Yeah, you could put the sep equal nothing if you wanted, but that's the default for sep. Okay. So if we want to write numbers, we have kind of a problem. So we're going to do a write, call some other file numbers.txt. Okay, so if I have a file and I want to do an in file, now an out file, do an out file dot write 12, or better yet, let's have a variable. If a variable x is equal to 12, we're going to do this. Okay, we do that, and then we have to do our out file dot close. There's an issue. Okay, the issue is we have to write strings to our file only. We can only write strings to files. We can only read strings from files. Okay. So to fix this, we're going to have to use the str function. It works just like int and float, but it turns it to a string. When you do that, then you're going to be okay. Okay. So once we've done that, to be able to get that back now, so let's now go to our in file to read. Okay. And we do our, say, x is equal to in file dot read line. At this point, x, so if I print the type of x, I gotta have the right name of the right file. But you see, it did tell me that the x is, it worked before it died. X is a string. Okay. So whenever you're reading a number from a file, you have to do this. I can do int around all that stuff, just like we do when we're doing input. Okay, and now if I print x times 2, life should be good. Okay.
I guess it makes sense why they put exceptions and tries on that, because you can easily kill your file.
Yep.
If you don't put it in the right area or
Yep.
the right type.
Notice that the multiplication of a string just does it twice, which is weird. Yeah, if you get the name wrong here, then it's going to blow up, and you don't want it to blow up. Okay, so we're going to have to deal with those errors again that's coming on Friday. Okay. So that's once you've made that conversion. But again, if I tried to open instead philosophers, for reading, and then do the same thing, that will work. But if I try to do the int there, here's the other issue. That has a string in it, so it's going to blow up when I try to do an int. Okay. So we have to be able to figure out all that stuff. Okay, so we can use while loops as we're going through, okay, which is a useful thing to do. Okay, so there's an example of that on page 307. Okay, so the idea behind this is that we're going to have a while loop. Let's go to our philosophers again. Open it for reading. Okay. Not going to do that. I can do my while loop here, and when it gets to the end, the line that it reads is going to be equal to nothing. Okay, so I can say while is not equal to nothing, and that's going to catch it before it dies. Why did I not indent? That's why I didn't indent. So once I've done that, okay, and I've opened this for reading, then I can say whatever x is equal to end file dot read line print, and that should go through but I'm gonna go through every time, because what's gonna happen, let me show I got this right order, so I'm gonna. Other way around. It shouldn't matter. I just have to make sure that I'm reading it again. Actually, there's no line yet. The first line you have to read before you get there. That's what it is. Yeah, like loops before, because that line has no value at this point. It'll give me an error, so you have to read it first. That's what I'm missing. So I read the first line, I check to see if it's empty. If it's empty, I don't do anything, but if it's not empty, but I want to print and then read. I knew that was the wrong order. So now I can print X, so X now has values up there, and then get a new X, okay? So this should print things out. Doesn't like something. Oh, read lines one word. Does like something. Oh, I did it twice. Click and paste. Oh, because I'm not using line, I'm using X. There we go. There we go. Okay, so again, it's going to end when it gets to a blank. Okay, and there's a blank at the end of every file. Okay, so that's the idea here. We're going to open the file for reading. We're going to read the first line. Then we're going to go into a while loop while we're not returning a blank. We're going to keep going, keep doing whatever we need to do. Okay, that could be anything at all that needs to happen. Okay, there's a shortcut way to do this because Python is Python. And we can use a for loop. As always, for loops are a little bit quicker. I can just say, I don't want to do that. For some variable, we call it line in file. Okay, so we're going to say for every line in file, we're going to print out that line. Okay, this will do the same thing. Okay. So we're going to see Python do this a lot with these fors. Okay, so we're saying again, the line is going to be the local variable name for every line of the file. So we're going to go through in file one by one, pull out a line every time, and then do something like that. Okay. That works identically to the while loop that we just did. The while loop has more lines, but does offer a little bit more control in some flexible situations you may need it. But in general, the for loop works well. Okay. You have a hard time getting your head around this one, then do the other one, and you'll be okay. Okay. Are there questions about any of this stuff so far? This is like a new paradigm, right? This is stuff we want to talk about.
How often is that you accidentally put like W instead of A up there that completely erases everything you've done?
Usually per career once, because it is so horrendous when it happens. When I was working as a web developer, as a webmaster at the university, there was this giant file. It was very great. Some catalog was up there. We had to convert it to HTML. I went to upload it, and I uploaded the wrong version. I uploaded like the 2-page summary, not the 50-page thing, and totally like that. Oh, and had to recreate it. Oh, but actually, I had underlings. I had to make them. Oh, okay. It's good to have minions, but then I had unhappy minions, so that's its own problem. Keep the minions. You're mad.
That's what we have to offer.
We never let them know they're anything other.
That's why we have a leadership class specifically for computers.
Yes. It's file. You have the exact same stuff because you have to open it, and once you open it, you should be able to use it. Okay. The issue could be, I don't. Are you on a laptop? Yeah, you shouldn't have a problem. Yeah, I'm not sure what's going on with that.
Maybe you have to specify where it's going.
You shouldn't have to. It should go to default, unless in some ways you can't write it. That's why the computers in here sometimes it's weird.
Let me try.
But you're on the computers in here. I understand that.
Let me try it on the computer.
So, is it because we don't have the files specifically? Yeah, you created it first? If you don't create it first, you can't.
Well, even though I was reading those, it didn't somehow that error.
How about automatically created it if it exists?
If not on a read, on the right, well, that's really weird, I'm not sure.
Oh, yeah, right.
Yeah, a read assumes that it's there.
Yes.
Yeah, which is weird, but you make sure it's in the same directory, I guess. I don't know, that's strange. Again, that's why we're getting exceptions on Friday, because when you go to files, you got a whole new level of heartache. We've been playing just in our sandbox now. Now we got to deal with somebody else's sandbox. So, and you know how other people's sandboxes are? They're dirty. People are dirty in general. That's what the pandemic has told me. People are dirty. All of them. Germy, awful. If I could spray you all with disinfectant in the room, I'd do it. Trust me. If I could teach them a
But one
bubble.
day I don't bring my glasses.
Yeah. Anyway. Is it a file name issue or a directory issue or?
Yeah.
Yeah, it's got to be in the same directory. I mean, and that sometimes can be weird. Okay. Okay. There's one more example in the book, but we kind of have time, but kind of don't have time. I don't want to go through all that. I'll talk about it. And it's in the spotlight. Okay. On working with files on page 309.
No.
So that one is saves a sequence of video running times. Your video time text file. It's not bad to go through that. And again, just to give yourself some more practice with how that works. Okay. So that's going to go through. Again, there are two parts to all these things, right? You have to have a program to create a file. Well, you don't actually. You can create a file in a text editor if you want. Let's say you want to create a quiz of the President of the United States. You could go find an existing text file out there, load it onto your computer, and then use that as the basis. Okay, so you don't have to read, or you don't have to write your own text files, but you have to have access to a text file. Most of our examples, we're going to create a file, one program, read the file, and do something else with it, another program. They could be the same file, or same program, could do both, but there's those two parts to it. Okay. So there's a couple of homework problems that I didn't write down which ones they are. Anybody know? Yeah, it sounds. I don't usually give 3 on 3 and 4 first. Yeah, you're getting advanced.
Yes, next time is 34.
Okay, that makes sense. Yeah, so with problem 3, you're going to write a program that asks the user for the name of the file. The program should display the contents of the file with each line preceded by a line number and a colon. Okay. So 3 and 4. So for that one, you have to create a file first, right? So you can just create a text editor, you want to put it. But whatever file they give you, you're just going to print it out and have a counter that's going to count the line numbers. Okay. Shouldn't be too bad. Concatenate those together. Okay. And then 4 is an item counter. Assume that a file containing a series of names as strings called names.txt and exists on the computer's hard drive. Write a program that displays the number of names that are stored in the file. So they give you a hint, open the file, and read every string stored in it. Use a variable to keep track of the number of times that they're read from the file. So again, those are both counter problems to some degree. They'll use a while loop to keep track of it. So, and for both of those, it assumes that there's a file, you just create a text file or do whatever you want. Okay. Other questions about any of that stuff? So this, again, is new territory for us. I think working some bugs out to make sure that it's all working the way you expect. Okay, so that's it for today. I would encourage you to go ahead and look at 3 and 4. In particular, again, it's a big week for us in that we've got files, which is new. Exceptions are also new. Okay, so we're going to have another new topic to expand our world even further. Okay. And then next week, we get into data structures.
Yeah.
We get into lists and tuples,
Yes.
which really is, this is the beer that made Milwaukee famous. The lists and tuples are so amazingly powerful. We've already seen them without knowing it. That it's why Python has the successes, one of the top 3 programming languages in the world.
And then we get the dictionaries.
Xander mentioned in the
Yep.
future that like he'll just hijack the expedition group for all those CSE kids and like before the first day teach them lists.
There you go. This messes with your mind.
Okay, so here's the thing, when I took my Python class, half of the, I didn't learn, I think